right, so today we're doing like this. Most of the problems on your work today factor. They're different. They're kind of entertaining. I enjoy them, okay? So most of the problems today are like this, and you can factor and solve. And we will be finding real and imaginary solutions. This one happened to have 4 real solutions, but you'll see sometimes we have to use the quadratic formula or the square root method to find other imaginary solutions. If you cannot factor by hand, then we might have to go to the synthetic division route. So example 1. Example 1, find all solutions to the equation.
There was a chip.
Can't do that.
I'm so not waiting for you when you change the page.
I'll just look at it later.
Bless you.
Okay.
Just been my
We're going to find all the solutions to the equation, real and imaginary. We want to state the number of real solutions, purely real solutions, and then we're going to state the complex roots as well. Complex means that it's in the form a plus bi, where it has a real part and an imaginary part. But really, we just want to state the real zeros and the imaginary zeros, how many there are. So for the first function here, 9x cubed minus 15x squared plus 11x minus 5. It has 4 terms, so I'm wondering if I can do factor by grouping. No.
There's an 11.
Yeah, the 11 is really throwing stuff out there. Okay, so since I can't do factor by grouping, then we have to go to our calculator. We're going to go to the calculator and plug that equation in. And then you're going to do Zoom 6. Plugging it in, doing a Zoom 6. And it's kind of a funky little graph. Funky little. Looks like it passes through 1, and I'm just going to verify it is. It does have a 0 at 1. So it looks like it has 1 real root, which means what? 2 imaginary, yeah. Or non-real is pretty good. It works. All right, I'm going to use this 0 with synthetic division to help me reduce this polynomial to something I can solve. So I'm going to bring down the 9, and we're going to multiply and get what? 9. Combine and get?
-6.
Thanks. Multiply and get? Combine?
5.
Multiply?
5.
Combine? Good. All right. So we have our polynomial. Oh, sorry. I didn't mean to do that. I meant to say we're going to set it equal to 0 to find the roots. We had our factor of x minus 1 that we just divided out. And then what's our quotient? 9x squared minus 6x plus 5. This one is easy to set equal to 0 and get our root. But this one, 15 minus 3, no, that's not going to work, does not factor. And since it does not factor, what do I have to do? Yeah, the quadratic formula. All right, which is what? X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. All right. I'm going to do the quadratic formula, and I'm going to use the power of my calculator to make that go much more quickly. X equals the opposite of b, plus or minus the square root of. In my calculator, I'm just going to do the b squared minus 4ac. B squared is going to be 36 minus 4 times 9 times 5. So I literally just plug that right into my calculator and get negative 144. So that's the discriminant part, the thing under the radical, over 2 times a, or 2 times 9. So that, I mean, it's like a one-step thing when you do it that way, which is pretty nice. So 6 plus or minus, how does the square root of negative 144 clean up? 12i. Good. I, because the negative underneath, I comes out, and square root of 144 is 12. And then I'm going to divide both of them by 18. And I get x equals 1/3 plus or minus 2/3 I. Yeah, and 12 over 18 divides by 6. Yes, 0.3 is wrong.
No, not 0.3, just 1/3. So like that 1/3 plus 2/3 I, just like 1 plus.
Oh, you're saying 1 plus 2i over 3. No, that's correct. That's equivalent.
Why did you write it like that?
Why did I write it like this?
Yeah.
I'm always going to break it up. I'm always going to break it up so that it's in a plus bi form. So the a is 1/3 and the b is 2/3. But also I'm always going to do that just to reduce properly. All right. Good. So we had 1 real and 2 imaginary. All right. This one's a fun one. X cubed minus 27.
Oh, you're doing that formula.
Yeah, this was, I decided to do this one because it's just a good refresher of, oh, this is difference of cubes. Do you remember how to factor difference or sum of cubes?
Yes.
I think it was like a minus
Plus or minus 1 plus 1 minus.
Small bubble,
Big.
small bubble, big bubble. And what do the signs, how do the signs go?
Negative, positive, negative.
Minus, plus. The way that works, keep the sign, change the sign, always positive. That's the rule. Keep the sign, change the sign, always positive. All right, what gets cubed? X gets cubed to give us x cubed. What gets cubed here? 3. 3 cubed gives us the 27. And then to fill out the big bubble, do you remember?
Oh, yeah.
Square the first, so that's x squared. Multiply in the middle. And you get to ignore the signs. We've already dealt with the signs. That's the beauty of the pattern. It's just a 3x. 3 times x. And then square the last thing. 3 times 3 is 9. That's the pattern. Square the first, multiply in the middle, square the last. All right, so we factored that. This bubble is x equals 3. But what do we have to do for this? Yeah, again, the quadratic formula. All right, so x equals the opposite of b plus or minus the square root of. Now in my calculator, b squared minus 4ac is going to go in my calculator. B squared minus 4 times a times c, and I get negative 27. So that goes in my radical. All over 2 times a. All right, so I get negative 3 plus or minus. How does radical negative 27 clean up? 3i radical 3. Very good. 27 is 9 times 3. The square root of 9 is 3. What's the square root of negative 1? I, and then the radical 3 stays, and then each of these gets divided by 2. All right, do you guys have any questions for me?
Yeah.
This had 1 real root And how many here?
Just two.
2 imaginary roots. Okay. All right, ladies and gentlemen, today on your worksheet, try to factor first. All right, most of them factor. Number 2 does not, but everything else does. All right.
What on number 2?
Number 2 is like letter A.